Okay. So we are going to look this morning at graphing tan. Now, tan appears a little bit different than what sine and cos do. So sine and cos, we use the 90-degree angles all the way around the unit circle in order to get our values. But tan works differently because we use sine over cos in order to solve for our tan value. So just to look at the unit circle then. Okay, at 0 radians, my cos and my sine are 1 and 0. Okay, my tan value is y over x. All right, because tan is sine over cos or y over x. So when I take 0 over 1, I get 0. Now, right here, I put a negative there. I have root 2 over 2 and root 2 over 2. Okay, so at pi over 4, I have my tan value is 1. Then I go up to here at pi over 2, which is 90 degrees. I've got 0 and 1. And this is where I get my first introduction to an undefined value. I have 1 over 0. Now we can't have 1 over 0 because 1 over 0 is an undefined value. So now I go over to here, which is 3 pi over 4. That's this angle right here. I have negative root 2 over 2 and root 2 over 2. So now when I take the tan value of 3 pi over 4, it's negative 1. Then I go to 180 or pi degrees. And at pi, I'm back to 0. So what you notice is that the period for the tan function, so remember what period is. Period means where does it repeat itself. The period for a tan function, it all occurs in pi, as opposed to sine and cos, which goes all the way around the circle. So when I'm graphing my tan, okay, all right, so on page 168, they want us to graph tan from minus pi to 4 pi. Okay, so that means I have to start back here somewhere behind the unit circle. So this would be minus pi over 4 here. Okay. So looking at my unit circle, now I'm going to do this, it's going to look a little bit smaller. I know it's not ideal, but looking at the unit circle, so now I'm going backwards. So at 0, I'm at 0 here. At negative pi over 4, that's down here. My tan value is negative 1, right there. At negative pi over 2, my tan value is undefined, so it goes like this. Over here, my tan value is 1. Back to pi, my tan value is 0. Okay, now when I go across here, pi over 4, pi over 2, 3 pi over 4 pi. I'm going to do it again, except now I'm going to go in this direction. So I get 0, 1, undefined, -1, 0. So I go 0, I go to 1 here. 3 pi over 2 is undefined. I go -1, 0, 1. Okay. So looking at my graph then, this is how it looks. This goes up like this, approaches. So it goes here, like that. Start down here, goes like this. This value right here will be an asymptote. And so it just continues like this all the way through. And at every odd value of pi over 2, I'm going to end up with a an asymptote. Okay, so this is my tan graph. So this is pi over 4. That's 3 pi. This is, sorry, pi over 2. Let me write those in different colors so it's easier to see. So this is pi over 4, pi over 2, 3 pi over 4, pi. And as you can see, it goes back to 0 right there. So where else this is quite a bit different than my sine and my cos graph. All right. First thing, the domain. Actually, you know what? Let me do this on a separate page here. Just going to sketch this one more time. Okay, so first things first. The easy part is my range. My range, the lowest it goes is negative infinity. The highest it goes is positive infinity. So therefore, my range for this, y, such that y is an element of all reals. Okay, so there's my range. My domain is a little more complicated. We do need to know it, and we do have to be able to write it correctly. So let's do this slowly. My asymptotes are at pi over 2, 3 pi over 2. The next one would be 5 pi over 2. Then I would go 7 pi over 2. I can't answer that right now. Not sure who this is. Okay, so my domain. When I'm writing out my domain for this. So again, I write it out as follows. X such that. X is an element of all reals. So there's my starting point. This is exactly how we do sine and cos. Now, X cannot equal. Now, if you remember from the third section, or from the sine and cos section, to make something a odd number, I write it as 2k plus 1, and then pi over 2. That makes it an odd number, and then I have to write k as an integer. So this is probably the most complicated thing that you're going to do when it comes to graphing the tan function, is writing out your domain. So if you look on page 168, it asks you what the zeros are for tan over negative pi less than theta less than 4 pi. Okay, so the zeros occur at every pi value. So 0. So if I was going back to negative pi, so negative pi would be your first one. So you can fill this in your workbook. So I've got negative pi. My next one is 0, 1 pi, 3 pi, right? So it's the odd values. Nope, it would be all values, my bad. So this would be 2 pi here, and then 3 pi. And I guess if we're including it, I don't know what the domain is, but if we're including 4 pi, yeah, you are. Those are your zeros. Okay, so you can write those in. It says determine the ones. We've already done all that. So over the domain minus pi less than or equal to 4 pi. So I'm at the bottom of the page there. The slope of the terminal arm is -1 when theta is equal to. So -1 is down here. So in this case, it would be minus pi over 4 here, 3 pi over 4 here. Where's the next one? It would be at -1. 5 pi, 6 pi, 7 pi over 4 would be the next one. And then the next one would be 11 pi over 4. So at the bottom of the page, if you're filling that in, you can do that. All right. Okay, so this is what we have so far. That's my tan graph. Okay, you can use your calculator to sketch these. Again, they want to be in radian mode. In your pre-calculus class, not mine. Sorry, you're not in my pre-calculus class. Okay, the last thing I want to do today, so grade 12s had a pretty slow day yesterday with you. Yeah, amusing. Okay, so with yesterday's being slow, I'm going to go into 5.4 today. I want to wrap up chapter 5 this week. Okay, so let's go to page 175. And it says solve each equation over the specified terminal. So solve sine x equals 0.5. And it's over 0 degrees less than x. So you can see that we're working with degrees right now. So this again is a unit circle question. Okay, so one of the ways in which we could do this is we could graph it. All right, so that's one of the things we could do. So if I graph this, okay, 360 degrees here, 720 degrees right here. Okay, so if I were to graph two equations, the first one being, if I put this into my calculator and I go y1 is equal to sine x, and then I do y2 is equal to a half, I would see that I would get this right here. And my intersection points here would be my solution for this. Okay? But there's an easier way in which we can do this. All right, the easier way is to use my unit circle. All right, so where on my unit circle is sine equal to a half? Well, right there, 30 degrees, 150 degrees. So for this answer here, I could go x is equal to 30 degrees, 150 degrees, and then I got to keep going around the circle, 390 degrees, and then 540 degrees. So those would be these coordinates right here. Okay, so there is a way in which we can graph them. However, graphing is probably not the most effective way of doing this. The most effective way of doing this is just to use your unit circle and calculate those out. All right. Now, just look at B now. B has a change. It has this here. I'm just showing you this on this graph, but I'll show you how to do it again in a second. So look at sine 2x. How does the 2 affect my graph, my sine 2x graph? How does it affect it? Well, instead of this being 360 degrees, the period changes. It repeats every 180 degrees. So what that means then is this now is 180 degrees. This is 360. And then I would have to keep going to 540 and then to 720. So what I've done is I've increased the number of solutions. By putting that 2 in front of the x, I've increased the number of solutions from 4 solutions to 8 solutions, because I have to keep going around the circle. So again, I could graph it. Now, there is a way in which we can do this algebraically that I want to show you. So here's how this works. Sine 2x equals 0.5. Okay, now this is another one of those questions. Okay. This is another one of those questions right now. What I'm going to do is I'm going to switch 2x to theta. So I'm going to go sine theta equals a half. Now, remember, the period changes, so therefore, I've got to find more solutions. So what I'm going to do is I'm going to do it like this. All right, once around the circle, where does theta equal 1/2? Well, we just did it. 30 degrees and 150 degrees. But I want to keep going, okay? Because it says between 0 and 720. So 390 degrees. Oh, I think I did this wrong in the last one. 510 degrees. Let me go back. I made an error, I think. Yeah, I put 540 here instead of 510. Okay. All right, so I have that. So the next one on top of that would be to add 360 to that, would give me 750 degrees, which would be outside of my domain. My domain says it only wants to go up to 720, but I'll show you why I got to keep going. So then I added 360 to this. That gives me 870 degrees. So now I've got 1, 2, 3, 4, 5, 6 possible values. So theta is equal to that, but theta is 2x. So now what I do is I go 2x is equal to 30 degrees. 2x is equal to 150. 2x equals 390. 2x equals 510. 2x equals 750. 2x equals 870. All right. So I let 2x equal all of those, and now I solve for x. So I divide. x equals 15 degrees. X equals 75 degrees. Whoops. X equals, what is that? 39 divided by, my math skills are great this morning. 39 divided by 2, 195. Divided by 510. $375. $435. All right. So far I've got that. But if you recall what I said earlier, we should have 8 values here. All right. So I have to keep going. So now I'm going to add another 360 to this, which again, I'm copping out today. 1,110 degrees, and then 1,230 degrees. So I've got that. So now I go 2x is equal to 1,110 degrees. 2x is equal to 1,230 degrees. Divided by 2. There you have it. Okay, so by putting that 2 in front of the x and changing it to sine 2x, I've now shrunk my period, and I get multiple sine graphs or curves between 0 and 720. So you could check this on your calculator. You could change your window so that it was larger than, like, put it to 750 as your max. Make sure your calculator was in degrees. Do zoom trig. Punch in sine 2x. And if you checked all of your intersection points in which you had y equals sine 2x as y1 and y2 is equal to 1/2, you would find that you would have 8 values between 0 and 720 that work for x equals, or sorry, sine 2x equals 0.5. Okay. The top of page 176, or the middle of that page, they show you that sine graph between 0 and 720 and how they would do that question. So that gives it to you. So the solutions are x is equal to, and I listed them, 15, 17, 195, 255, and so on there. Okay? Now, the last thing answer a question here. Okay, the last thing I want to look at, if you actually look on page 177, they use that sine regression. Mary, how do I get the graph? Okay. So I'll talk you through the graph on the calculator. So the first thing I want you to do is go into y1 or y equals. Make sure the stat plot isn't on, okay? And then type in sine 2x. Your x again is the button next to the alpha. I don't know if you can see that. So your x is that right there, okay? So I've got sine 2x, all right? Then I want you to, let's zoom. We'll try this first. Actually, the first thing I want to do, sorry, I'm backtracking. I'm going all over the place here. Change your mode to degrees. Mode to degrees. So that's the first thing I'm going to do. Make sure my mode's in degree. It is. Go back to y equals. Hit enter. And now hit zoom trig. So go zoom trig. Zoom 7 is zoom trig. And I've got my graph. Now, let me know if you got that to work. Okay, perfect. So now what I want you to do is let's go to our window. And my window is like minus 352.5 to 352.5. So what I'm going to do here is I'm going to change my window to whatever it says. It said my domain. So that's my X minimum, X maximum is 0 to 720. Okay. So let's go. My window is going to be, I'm actually going to do something different. My X minimum is going to be 180 degrees. My X maximum is going to be 750 degrees. And then my X scale can still be 90. My Y min still 4, 4, and 1. That's okay. So let's change our window right now, minus 180 to 360. Okay. And then I graph it. So I actually have looks like three full graphs between 0 and 720. Okay. So now what I didn't do and what I should do is do this now. Put y2 is equal to 0.5. So let's go to y2. Let's put in 0.5 there. And then let's hit graph. Okay. Once I have that, I can go second function trace and calculate my intersection point. So I'm only going to calculate the one intersection point, which is 9.57. So I do have an error that I made that I want to talk about in a second. So my intersection point gives me, my first one gives me 15 and 0.5. All right. Now I've messed this up. So I'm just going to go in here and erase this. This was wrong. I'll explain that in a second. Okay. So right now I'm looking at my graph. Maybe I'll pull it up on here and see if you can follow. Read all graphs. Oh, where did I go? Okay, it's probably not ideal. I'll try and do that, see if that helps you. I don't know how well that turns up. You got 255 as one of them, Roy? Okay, I'll have a look in a second. So there's one graph. Now I'm going to graph that. Okay, so 720 is what? 4. Okay, so pi's 180, 360, 540, 720 is right here. Ah, I did erase it and I shouldn't have. You're right. I left them on there. I panicked because I was looking at my calculator and I didn't have the right. Let me see what I put for my window. I messed my window up. It's 720. All those values were correct. Okay, so my intersection point. This is really hard to see, and I'm sorry, but my intersection point is right here. So y equals 0.5, and that gives me my intersection point. So that first one is at 15 degrees. The next one be right here. All right. Then here, here, and then all the way across. Those are my intersection points. So you could get the values for them. Okay, I want to see if I can undo what I did there. Well, there we go. Got them back. Okay, so all of these values right here should be on your graph. Okay, everybody's doing okay there? Answering. Okay. How's it going? Yeah, got 75 for one intersection point. Okay, perfect. Okay, that's what I want to see. Okay, Dalen, you got 2. Good, perfect. Okay. So everybody's okay with this so far? Again, the graphing works, but you should be able to do it without. So no, y-intercept isn't a part of that. Okay, because that's the y-intercept. Oops. Let me do it here. The y-intercept is right here, but that's not equal to a half. The y-intercept is at 0. Okay, so I'm looking for the first coordinate where a half and sine 2 theta are equal to each other. All right. I don't think we need to do a refresher on page 177 on using your stat plot. Okay, or maybe we should. Let's do that. So let's work on page 177 now. And let's go through all of what we have to do in order to graph using technology. Now, again, this is not going to be required on the exam. I'll just show it to you because it's in the book, but it's not something that we have to. It's used and applied, but not the exam. Okay. All right. So first thing that we do is we go to our stat. So you go to stat. So I want you to, again, follow through. Most of you have done this enough times that it should be second nature. So I go to stat first, and then I'm going to hit edit. So I'm going to edit. If you have anything listed in your lines on your stat plot, just go up to the top, hit clear and enter. That'll clear your whole column. So now my months are going to go in. So I'm going to enter into line 1. I'm entering all of my months. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I entered my months in. Now I'm going to enter in my, so that goes into line 1. So line 1 is my months. Line 2 is my temperature. Okay, so I got to put my temperatures in, minus 18.4, minus 13.4, minus 7.3, 0.1, 6.8, 11.9, 14, 12.3, 7.5, 0.6, minus 9.1, minus 15.7. Okay, so just take a second, put them into your stat plot. After you put them into edit, once you have that in here, go into your mode again and change it back to radian. Because if you recall from applied, when you're doing your trig regression, it has to be in radian measures. So make sure we do that. Now that I've got that in there, I go to my solver screen. So hit second function, quit. Now I'm going to put in, I'm going to hit stat again. And I'm going to find my trig regression, my sine regression. If you hit up on the cursor, it'll take you right to sine regression. So I go stat, sine regression. And then enter. Okay. All right. Okay. Now, remember to do this. So we go line 1, line 2. So second function 1, comma, second function line 2. Okay. And then you got to go to vars to find y1. So I go vars, function y1. So right now, my solver mode reads this: sine regression, line 1, comma, line 2, comma, line 3. And now I'm going to hit enter. So I get my trig equation. Okay? So my trig equation so A is 16.7936, B 0.494. Oops. Okay, So, all right. All right, where are you at, Mary? At the input there. Okay, I put sine regression, line 1, line 2, y. Okay. So then at this point, oh, I put line 3. Sorry, Mary. I should have had this, y, instead, okay. Yeah, everything's good. Okay, do you have the y here then? Line 1, line 2, and y. Okay, so far you're okay? Got it? All right, perfect. Okay, so now we're at this point here. We got our equation. Now we need to get it onto the graph. So the first thing I want you to do is go to y equals, and you have to put your stat plot on. So you remember how to do that? Go up to the top, hit enter on plot 1. I also have y equals 0.5 in mind, my y2, so I'm going to delete that one. So now I should have in y equals. So I've got this, okay, y equals, and then I can go zoom trig now. So hit zoom trig. So zoom 7. Now mine didn't work out very well. Mine did not work out great at all. So oh, I know why. This is not what we want to do here. My bad. This is what we want to do. That'll work out better. Do zoom stat. Yeah, mine looks like a quadratic too because I did zoom trig. Go zoom stat, Mary. So zoom 9, and then there's where we get. That's the graph we're looking for. Okay. So looking at the bottom of page 177, I can, excuse me, I let X represent my months, let Y represent my temperature, and it says use a COAST model to graph it. All right, so our trig, if you look at our graph, when we do the regression, it gives it to us as a sine regression. So what you want to do instead, using a sine regression, is they want you to do it in a COAST. So my A, my B, and my D are all going to be the same. So I have to switch my C in order to make it a COAST model for this. So A COAST, again, I don't like this. They have BX plus C add D, but that's just the way the calculator operates. So what we're going to do is let's find out what our maximum value is, because that's where the peak value is, where COAST is. That's my new C. So I'm going to use, for my COAST graph, I'm going to use A as 16.7936. I'm going to use B as 0.4694. I'm going to use C as whatever I calculate, and my D value is negative 2.7697. So this is different. This is different than what we did in the applied math. Okay, so this is different than the applied in that we are going to actually calculate using Zoom calculate and then find our maximum value. So let's find our maximum value using Zoom trace. So we get a maximum value of 14.02 at, and this becomes our new C value, 6.9575. All right. Did you zoom stat? Okay, so Rory, I'm working with you right now. So you zoom statted, and did you get your graph? Is that what your graph looks like, Rory? I got to keep going right now. Go back to the start of this video. You're not being ignored. In about 5 minutes, you can ask questions. I just need to finish this up and then I'll go back through it. Okay, so Rory, were you able to get that graph? You don't have a line through it. Okay, so if you don't have a line through it, Rory, you didn't do this right here. So go back to your solver screen. So I've got sine regression line 1, line 2. I got y. Okay, so go back. Make sure that you use that bars, that y bars on there, Rory. Plug that in. Okay, so, and then when you go to y equals, the equation should come up on the screen in your y equals. So hit y equals right now, Rory, and tell me if your equation came up in your solver screen or in your graph screen. It may not if you didn't press enter after it as well. That's also a possibility, Rory. So you have to go sine regression, second function 1, second function 2, then you got to go to vars, function y equals, and then hit enter. Okay, so if it came up in the y equals, now hit zoom stat. Oh, also, Rory, make sure that y2 doesn't have 0.5 on it. So, Mary, what I did is I used second trace maximum. I put my left bound right here. I put my right bound right here. Okay. And then I got my maximum value right there by pressing enter. And that's, so it gave me That's what it gave me there, Mary. Okay, same thing. Is the y supposed to be y1, or how do I get it to just, no, y1's fine, Rory. Okay, good. Y1 works. That's what we want. Sorry, Rory, I should have put that in there. Messed that up twice now. So that's Y1 right there. So make sure Y2, again, make sure Y2 doesn't have anything in it. So you get none of your graphs, you can't have any of the other graphs there. Okay, come on, man. Still getting the same thing. I think you can block them. Okay. Okay. All right, Rory, let's go through this again. All right, let's do this one more time. And that's fine. So you've got your stat edit. Give me a thumbs up if you got your stat edit, Rory. Okay, perfect. Okay, our mode is radian. So now we go to second quit, and let's run this again. So let's go back to our solver mode, and let's go stat, calculate, sine regression. So stat, calculate, sine regression. We hit enter. Now we're going to enter in line 1, line 2, and then we go to vars. Y1. And at this point, so I get vars here, right? At this point, I hit enter. Okay, so get all the way there, Rory. Hit enter, and I want to know that you see that on your screen. Give me another yes if you see that on your screen. Okay. Thank you. So now, let's go to y equals and check that your stat plot is on. Is your stat plot on? Okay, perfect. You have nothing in Y2, Y2, Y3, they're all blank, right? Go all the way down to make sure all of your graphs are blank except for Y1. Okay, awesome. Okay, now we're going to hit zoom and then go to stat. So zoom 9. Nope. You had something in one of the Y values, didn't you? Okay, so now go zoom stat, Rory. Does it appear? Okay. Okay, so now that that worked, let's try and find our maximum value. So go second function trace, maximum. Make sure your left bound is to the left of that point, your right bound's to the right of that point, and then hit enter. Okay? All right, so 12s, that takes you to the end of your unit. What I look to do is on Friday is I'll try and send you out an assignment. It'll be put out on Edmodo. So if you want to do it, great. It'll give you kind of somewhat of an assessment as to how you're doing on this. Okay? But you have the next 2 days. You should be done. You should be working on 5.3 and 5.4 today and tomorrow, and then a review on Friday. But I would like it if you checked in tomorrow, sometime during the morning, to let me know where you're at and how you're making out. All right? So I'm just going to end this stream, and then I'm going to go back up on for another 45 minutes to answer questions from any groups. So you guys included. If you have questions, you can come back on, but I just need about 5 minutes to shut this one down, and then I'll come back on to answer other questions. Okay?